So now in this video, we're going to use the trim pot to set a voltage again. This time though, we want to set the voltage directly across a load, which a trim pot does a terrible job because you put a voltage across it. You can go anywhere down to 0 volts in this case, or up to 5 volts, anywhere in between. But the voltage that gets through has to go through resistance. So adding a load directly to it will just divide that voltage further. It will drop down. So we are going to give the signal to an NPN bipolar junction transistor. I'm using the 2N3904. Doesn't really matter, but may have a different pin layout if you use a different one. So in any case, we have the emitter here. The load follows it. So this is known as an emitter follower or a common collector. And we have a 10,000 ohm resistor right there. Just helps establish that voltage. Some loads may throw it off. But in case we have the trim pot set to 0 volts, I'm going to have to get to about 2.6 volts to get 2 volts across the resistor and the LED. It's very faint, which you can expect at 2 volts. If I turn the trim pot all the way up to 5 volts, so 5 volts to the base, we're still losing 0.6 volts to the emitter because there's a diode drop right there. And so we got about 4.4 volts across the resistor and the LED and our extra resistor there, but doesn't really influence the current going through the load. The current that's being provided is coming from the collector, not the trim pot. It's just setting the voltage. Just a speck of current going base to emitter means a lot more current will flow from collector to emitter. So it's going to let current flow till it builds up to that voltage minus the drop right there. And thus all the current basically is coming from the collector. It's not throwing off the voltage of the signal probably at all.